Chelonia, a lightweight, self-healing, distributed storage system. With Chelonia, anyone can create a cloud for storing files. Chelonia users can easily upload and download files to the storage cloud, organize them in collections, and share their files with any other user of the system. Chelonia has a global hierarchical namespace that allows all users to see exactly the same tree of files and collections. Files can be referred to by logical names, which are paths in the Chelonia namespace. They are similar to the paths in normal local file systems. Files in Chelonia are replicated. The system ensures that a file always has the specified number of replicas on a best effort basis. The storage nodes keep replicas of the files. It is very easy to create a storage node from an empty directory on any machine just by installing a small subset of Chelonia. Chelonia users can assign access policies to files and collections in the system to grant access to individual users. In a grid environment, it is possible to grant access to entire virtual organizations. Chelonia comes with a Fuse module, making it possible to handle the entire storage cloud as a local directory. Chelonia is accessible from grid sites supporting the ARC middleware. Input and output files can be specified through standard job specifications, as well as with the ARC client tools. The command line tool is an effective way to manage files and collections in Chelonia. For example, to list the contents of a collection, you only need its logical name. With Fuse integration, it is possible to use local file browsers to view files in Chelonia. This way, a file can be uploaded to the system by simply dragging and dropping. To organize files in Chelonia, collections and sub-collections can be created, and the files can be moved between collections. The files can be downloaded by any user who has proper access rights for them. In Chelonia, all files have an owner, and this owner can define precisely who can access it. The capabilities of Chelonia are provided by several interconnected web services. The librarian services store and manage the metadata for all the entities in the system. The shepherd services store and manage the storage nodes with all the actual file data. The bartender services serve the users by negotiating with the other services to fulfill the user's requests. It is possible to deploy Chelonia in a centralized way, where the services have only one instance each on the same machine. This creates a web service-based storage cloud from a single machine. To make replication possible, more storage nodes are needed, each one managed by a shepherd service. By adding a storage node, the file can now have two replicas, and the second one is automatically created. By replicating not only the files but even metadata and deploying more librarian services, the system can be more fault tolerant, and the system load can be balanced more effectively. The bartender can communicate with any of the librarians with the same result. To eliminate single points of failure, more than one bartender is needed in the system. The users can randomly choose any of the available bartenders, and the system behavior remains the same. Because everything is replicated and distributed, even if some services are not available for a while, the users can still use the system without serious problems. The librarian services use a simple but replicated database to store all the metadata. This makes it possible to have multiple librarians which work on the same database. The database is provided by the AHASH service, which uses the Berkeley database for replication. Chelonia is a solution for flexible, distributed, replicated storage. It creates a storage cloud accessible from the command line, file browsers and grid systems. Developed by the KnowARC project, it draws on years of experience in distributed computing to create a powerful but simple solution for online storage.